All right, here we are for video 3 for section 5.1, and we're going to talk about vertex form of a quadratic equation. So we had used general form before, and now we're going to talk about vertex form. In MyOpenMath, in your textbook, they called this standard form, but I'm going to call it general form and vertex form. All right, so vertex form looks like f of x equals a, the same a as in general form, x minus h squared plus k. And in this form is convenient because actually if it's in this form, you can read right off what the vertex is. The vertex is hk. So if we're looking at an example, let's just look at this example right here. F of t equals minus 3 parentheses t plus 2 squared plus 4. Right off the bat, we can compare this here and we can say, okay, well the vertex is t minus negative 2. So h is equal to negative 2 and k is equal to 4. K is equal to 4. If it looks like plus 2, then we have to switch to t minus negative 2 to match the values, right? T minus h. So h is negative 2 and k is positive 4. And you can see, looking at the graph, that that certainly is true. The vertex is at negative 2, 4. This is a convenient form to use if you're thinking about how your new quadratic has been transformed from your basic quadratic, which is f of x equals x squared, that quintessential quadratic, f of x equals x squared. So if we're looking at it in this form, it's much easier to see what has been done to the function as far as horizontal shifts and vertical shifts and reflections and all that kind of stuff. So if we look at f of t equals minus 3 t plus 2 squared plus 4, and we compare that to f of t equals t squared, we can see that, well, there's been a shift inside, right, a horizontal shift to left. There's been a vertical shift 4 up, right? And also the negative means we've been reflected. And finally, a vertical stretch of 3, stretched vertically a factor of 3. So if you think about what the regular old x squared looks like, let's see if I can draw it pretty well here. It looks like this. Just trying to hit the actual points here. And then this, well, that's not the world's best x squared, but you get the idea. It has been shifted left, shifted up 4, reflected across the down, and then stretched vertically a factor of 3. So that's one reason we like to use vertex form. There's some other reasons why it comes up and it is pretty handy, but let's practice with it a little bit first. All right, let's do an example 3 using getting from the general form to the vertex form. I've decided that I don't really care for the function that I originally chose, and I'm going to change it to v of x equals 2x squared, nope, 3x squared, 3x squared minus 6x plus 7. One thing, I didn't really like switching to t, and another thing, it had a bunch of fractions when I worked it out, and I just think for our first time through, maybe whole numbers would be better. All right, so let's find the vertex first, and then we're going to rewrite this function in our vertex form. So the first thing we need to do is find the vertex. Find the vertex. X equals minus b over 2a tells us the x coordinate of the vertex. So in this example, a is 3, b is negative 6, and c is 7. So minus 6 over 2 times 3 equals 6 over 6, which is 1. That's the x coordinate of my vertex. And to find the y coordinate, I plug in the x coordinate. V of 1 equals 3 times 1 squared minus 6 times 1 plus 7. So that's equal to 3 minus 6, which is negative 3, plus 7, which is positive 4. So my vertex is 1, 4. So now how can I write this in standard form? Standard form in math. How can I write this in vertex form? I have it up here. Switch colors really quick. I have it up here in general form, and I want to write it in vertex form. Well, I know my h value is 1, and my k value is 4, right? So I'm going to plug it into my, let's write general standard form here, and then we'll plug everything in. So f of x equals a x minus h squared plus k, right? Let's plug this in for our v of x. So our v of x is going to be 3 that's our a value, x minus 1 squared, that's the x coordinate of our vertex, plus 4. Now, did we do this right? I hope so, but there's a way we can check right now. This is what we think it is. We can check by multiplying this all out. Multiply out to check. All right, let's FOIL this guy out. Remember, x minus 1 squared is x minus 1 times x minus 1. So this is going to be equal to 3 x squared minus x plus 1 plus 4, which is equal to 3. Inside here is x squared minus 2x. I did not mean to zoom in so much. X squared minus 2x plus 1 plus 4. Distribute the 3. 3x squared minus 6x plus 3 plus 4. And the last step is just to add those like terms, 3x squared minus 6x plus 7. All right, so this is how we go about if we're given a quadratic function that's in general form, we can rewrite it into vertex form by simply finding the vertex, plugging it into the formula for vertex form, and using the same a value. The same a value is the same between the two forms. All right, let's try and find another one. Let's go ahead and find the function in standard form of the quadratic from the graph. And I meant to say general form. General form. It's a lot of terms there. General form from this graph. So the way I'm going to do this is almost the exact opposite of the way I did the last problem. I'm going to write this guy in vertex form. So the first thing I'm going to do is write it in vertex form, and then I'm going to multiply it out to get it into general form. All right, so how are we going to get this into vertex form? Well, luckily the vertex is very nice. It is over 2 and down 2. So the vertex is over 2, down 2, negative 2, 2. All right. So let's go ahead and plug in what we know. We know that f of x equals, well, some a value. We'll have to figure that out. X minus 2 squared, that's the vertex, plus negative 2, that's the k value. H is 2, k is negative 2. All right, how am I going to figure out the a value? How am I going to figure out the a value? Well, I'm going to figure it out kind of the same way I found out when I was using linear equations, how I found the y-intercept. I'm going to plug in a point on the graph, and one point that jumps right at me is 0, 10. So I'm going to plug in 10 for my function output value and 0 for my input. This tells me that 10 equals a times negative 2 squared minus 2. I can solve this for a, no problem. First thing I'm going to do is add 2 to each side. So 12 equals a times negative 2 squared. Negative 2 squared is 4. 12 equals a times 4. I want to undo the times, so I divide. A equals 3. And this opens up, so that matches with what I think. So now I come back up here and I plug in my a equal to 3. F of x equals 3 x minus 2 squared minus 2 plus negative 2. Now if I want to get that into general form, I need to multiply it out. I wish I'd drawn a less of an arrow, but that's okay. So let's multiply that out. F of x equals 3 x minus 2 x minus 2 minus 2. Okay. I need to FOIL this out. F of x equals minus 3 x squared minus 2x minus 2x plus 4. I'm running out of space a little bit, and I still have that minus 2 down there. That's that guy. All right, switch to the left here. F of x equals minus 3 times x squared minus 4x plus 4 minus 2. Distribute my negative 3. F of x equals minus 3x squared plus 12x minus 12 minus 2. finally, f of x equals minus 3x squared plus 12x minus 14. I must have missed a minus sign there because it should be plus 10. Okay, guys, what did I do wrong? Ten equals minus 2 plus 2, 12, 4, 3 equals a. X squared minus 2x plus 4. I don't know what I did wrong. Oh, Lord have mercy. It was positive 3 the whole time. Oh, well, okay. That is not, that's positive 3. That's positive 3. That's positive 3. That's negative 12. Okay, back up. Oh my goodness, sometimes missing a negative sign is the worst. Okay, back up. Here we go. F of x equals 3x squared minus 12x plus 12 minus 2. F of x equals 3x squared minus 12x plus 10. And that's my function in general form, and up here was my function in vertex form.